As you've seen in some labs, some salts are not fully soluble. Maybe they're slightly soluble or they're insoluble. This has to do with their solubility. So we're going to look at calcium hydroxide as our example. Calcium hydroxide, CaOH2, is slightly soluble in water. 0.19 grams of calcium hydroxide can dissolve in 100 milliliters of water at 20 degrees Celsius. So if we had a beaker and we put 100 milliliters of water in it, and I put in 0.19 grams of calcium hydroxide, and I mixed it up with a magic bean, all of it would dissolve into invisible ions in the water. It would look like transparent water, like normal water, because it would all dissolve. However, if I put just even one more molecule of calcium hydroxide into our beaker here, it would not dissolve. That is because it is slightly soluble, and at this amount, the limit of solubility has been reached, and this is known as saturation. You may be familiar with saturation in non-chemical ways. For instance, if you're trying to wipe up a spill and you use some paper towels, there's only so much liquid that the paper towels can hold. At some point, the paper towels become saturated with water and they can't hold any more water. Many different salts have different saturation points, as in how much of that salt can dissolve into the water. When something reaches the highest amount that can dissolve into it, that is called saturation. So 0.19 grams of calcium dissolved in 100 milliliters is the saturation point. We can understand saturation and the solubility of salts using mathematical reasoning. So let's look at scenario 1. Suppose that you have a beaker containing 75 milliliters of distilled water at 20 degrees Celsius. So, same temperature, which is important for solubility. A scoop of calcium hydroxide is added to the water and stirred until no more salt dissolves. When saturation has been reached, there is some leftover calcium hydroxide at the bottom, 0.24 grams of it to be exact. How much water must be added to dissolve the 0.24 grams of solid at the bottom? So, I have this drawing. In here, I have 75 milliliters of water, and I've put a bunch of calcium hydroxide into it. And at the bottom, there's a clump of calcium hydroxide, which weighs 0.24 grams. The question is saying, if I were to add more water, how much would I need to add to dissolve all of this 0.24 grams that are left over? So for 0.19 grams of calcium hydroxide, I need 100 milliliters of water to dissolve it. Now, if there was 0.19 left over in the bottom of this beaker here, well, it would be easy. I'd have to add 100 milliliters, but I don't have 0.19. I have 0.24 grams, so I need to figure out how much water I need. So we'll set this up as a proportion. And we cross multiply and solve for x. And we need 126 milliliters of water. This should make logical sense to you because we've got 0.19 grams, which is smaller than 0.24 grams. Therefore, the amount of water you need should be more than 100 milliliters, which it is, 126 milliliters. For the second part, if all the water in the beaker is evaporated, what mass of solid calcium hydroxide will be present? So we know that the answer is going to be more than 0.24 grams because that's how much is left over down here. But we need to figure out how much is dissolved up here and then add the two together. So for this, you'll need another proportion using the same numbers as before. So calcium hydroxide. So what this is saying again is that 0.19 grams of calcium hydroxide will dissolve in 100 milliliters. Now we're trying to figure out how many grams of calcium hydroxide are in some amount of water, and that's the amount of water up here. And I will leave the rest for you to figure out.